my name is Fernandez. I'm a senior network engineer with Gelecos, and today I'm very excited to talk to you a little bit about the evolution of AWS Public Cloud. In the beginning, AWS started with classic EC2 instance, providing basic infrastructure as a service, and networking was so simple since you could only launch an EC2 instance with either a public IPv4 or a private IP address on the 10 Class A network. In 2009, AWS introduced VPC, Virtual Private Cloud, allowing us to build our own and private network within an AWS region. And for this example, I will put US East 1. This is actually in Northern Virginia. So now, in order to launch an EC2 instance, we are required to define a region, a VPC, a subnet that usually comes with an availability zone and should be associated with a routing table. And for the ENI, we are also required to define a security group for allowing and denying traffic coming from that EC2 instance. If we would like to have any communication with the world, we can also create an internet gateway and attach it to the VPC and add a default route to that internet gateway. And then we will have communication with the internet. Or we can also leverage a NAT gateway for only having outbound communication with the internet. And that's pretty much it. Those are the basic networking services that we are required to define to have an operational EC2 instance running in AWS. But in a perfect world, we would like to build a fault-tolerant application on top of this EC2 instance. So we have the ability to create another subnet in a different facility, so availability zone B or BA, attach it to the same routing table and launch a new EC2 instance. And if we have the same application or the same size on both EC2 instances, we can create an elastic load balancer doing a health check with these EC2 instances. And we can also define an auto-scaling group setting some threshold if I need to run new EC2 instances. On top of that, we can define pretty cool DNS routing policies with Amazon Route 53, in which we can actually leverage a VPC, another virtual private cloud, in a different region. And for this example, we put US West 2. This is in Oregon. We can have an elastic load balancer doing health check to different EC2 instances, and we can define a DNS failover routing policy for an active standby configuration region base. Or if we would like to do a load balance, we can do a weighted DNS routing policy or latency or geolocation. So there are pretty cool stuff here with Amazon Route 53. And here we go. We have a fault-tolerant application with different facilities and different regions in AWS Public Cloud. Now, growing up in AWS, we have seen many organizations that like to start connecting with their on-prem environment. So let's see that we have a data center, and we also like to have this kind of failover pointing out to our data center. And we would like to have connection from our on-prem to our data center, from on-premises to our AWS Public Cloud. In that case, we have seen many administrators like to start uploading files to an S3 bucket. If you create a public S3 bucket, you can use the internet to load in those files. I would like to point out one thing here. S3, like SNS Topic or DynamoDB, those are AWS services outside of my VPC. And by default, my EC2 instances inside my virtual private cloud need to access to the internet in order to access to the AWS services outside the VPC. We have the ability to define S3 policies for writing and reading permissions, or we can also leverage identity access management to see who will access to my buckets, or we can create access control lists. But if we want to have a private connection from my virtual private cloud to my S3, then I can leverage a VPC endpoint. Again, modifying or adding a new routing table, and I can announce through BGP my S3 bucket in my virtual private cloud. In terms of connectivity with on-prem environment, we have seen many organizations starting with a site-to-site VPN. And for accomplishing that, we can create a virtual private gateway, also modifying our routing table. And AWS can set up 2 IPsec tunnels for having a site-to-site VPN. And this is a quick setup, but it's not as reliable as having a physical connection to AWS. So in 2001, AWS introduced AWS Direct Connect. I think that's the symbol, in which enabling clients to establish a physical connection to AWS at bandwidth of 1 gig and 10 or 10 gigabit per second. Or you can go sub 1 gig with AWS Direct Connect partners. Let me see if I can erase here better. So, in order to establish the AWS Direct Connect connection, we need to connect our on-prem environment with an AWS co-location facility, usually provided by AWS third-party partners like Equinix and many other facilities. And here we have 2 caches: customer cache with a router and AWS cache. That's AWS. And when we create a 1 gig connection to the AWS co-location, AWS create the cross connect, and we can define a private virtual interface to connect with our internal virtual private cloud. And for doing that, we can set up, for example, VLAN 100. If we would like to connect to our services outside of the VPC, we can leverage a public virtual interface. Let's see, VLAN 200 to connect to my S3 bucket. And then we have a full connectivity with a good bandwidth and throughput to our AWS environment. We have seen that in the site-to-site VPN, usually the bottleneck is in the bandwidth of your internet connection with your internet service provider, or the throughput that your firewalls or routers will be able to handle. And with AWS Direct Connect, we have a lot of options. For resilience, and you create another AWS Direct Connect connection, AWS by default will connect that with a different router. And you also have the ability to set up a link aggregation control protocol. I think that will be link aggregation control protocol, getting up to 40 gig per second. And this is amazing. This is a pretty great connectivity and low latency connectivity from my on-premises to AWS infrastructure in my VPC and in the AWS public services. So we have a fault-tolerant application built in different regions in AWS, and we have full connectivity with our on-prem environment through AWS Direct Connect and site-to-site VPN. Now we have a new challenge here, and I was talking about the evolution of networking, and we have a lot of AWS networking services. How we're gonna utilize this AWS Direct Connection with different regions. There is a workaround in which we can create private virtual interface and hosted virtual interface and create that communication by AWS in 2017, creating a service called AWS Direct Connect Gateway. And now we have the ability to connect with virtual private gateway in different regions and with a virtual private gateway in this region. And now, utilizing the AWS backbone network with my AWS Direct Connect port in US East 1, I can connect to my VPC in US West 2. And we have seen some limitation in AWS Direct Connect Gateway. Like the first and one of the most important limitations is that the virtual private gateway, Direct Connect Gateway, and virtual private interface must be on the same AWS account. And I cannot utilize the Direct Connect Gateway to connect two VPCs even if they are in the same account. For doing that, I need to leverage a VPC peering. And again, modify my routing table to access to my peering, or an AWS private link if I want to connect two specific EC2 instances. AWS released 3 weeks ago a service called AWS Transit Gateway. And with AWS Transit Gateway, now we have the ability to connect to multiple regions in multiple AWS accounts. And this is kind of amazing. We're so excited to work with AWS Transit Gateway. Actually, we have clients already utilizing AWS Transit Gateway. And we have seen also some limitations here, like encryption, a lot of work, and it's not integrated with AWS Direct Connect yet. AWS is planning to integrate Transit Gateway with Direct Connect in Q1 2019. So right now, we are also, and I think we need to make a different video to explain this, we are leveraging a next generation Transit VPC that will provide a lot of automation and orchestration to all our AWS services. And we might need third-party tools to leverage that. For example, Aviatrix, Cisco, Juniper. So the takeaways here is that AWS has been releasing many networking services for the last 20 years. And you need to have a team working behind the scene to leverage AWS services and third-party tools to follow the AWS well-architected framework and maximize your IT infrastructure.